is lesson 14, but we're going to start with a couple of review problems. Now, this right here might seem a little strange. We're not doing that because we have jumped over that module, and we're going to be coming back to it later on. So right now, I want you to, right here, I want you to do these two. I'm going to have that problem today. Okay. Is 45 prime or composite? So I need you to write either prime or composite, and then you can push that word somewhere over to the side, and then I want you to work out this problem right here. Okay, so we're doing this one, we're doing this one. Okay, so go ahead and do that, and if you get a chance, check that with multiplication. Keep trying to finish that up if you haven't quite yet. We cannot get a group of 3 out of 2, and so we would grab that 3 and look at 23. How many 3s? What's the most 3s I can get out of 23? Will, what?
7.
Okay, 3 times 7 is what? Yeah, so the 7 goes here. 3 times 7 is 21. And subtract that and bring down the 9. What's the most 3s I can get out of, bring down the 9? What's the most 3s we can get out of 29? Ishmael, what do you think?
9.
What is 3 times 9?
27.
Yeah, 27, so it's really close. Okay. 3 times 9, 27. And then we get 2 left over again. We bring down the 1. And a 3 and a 21 should ring a bell as far as a fact family. How many, Martin? We've got 21 here. How many 3s can I get out of it? 7. Okay. Do we have a remainder this time?
No.
No remainder. Okay. And to check it, I can take my quotient here, 797, and multiply it by the divisor. 3 times 7 is 21. 3 times 9 is 27, 28, 29. 21, 22, 23. This is a day where we might hear that occasionally. It's just a lot of rain today. Okay. All right, 2,391, and that is our dividend, and that's what we're looking for. Okay. All right. Now, I jumped to that one because I went ahead and turned it. But what about this one right here? And if you put prime or composite, why did you put it? Okay. 45. Do we think 45 is prime? Do we think 45 is composite? Nobody knows in the whole room. One hand in the whole room. 2 hands, 3 hands. Ha, 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 ha. Y'all remember the count on Sesame Street? Okay, never mind. I'm dating myself just a little bit. Martin, what do you think?
Prime.
You say prime. What do you mean? If it's prime, then what about it? What does that mean? Do you remember? Or did you just guess? You got a 1 out of 2 chance here of getting it right. So, all right. So you're disagreeing, okay? You think it's composite? Okay. Sorry, that didn't get to you.
No, he said, well, you later just looked it up. It's not in her seat. They hadn't told her either.
Gotcha.
Thank you.
Okie doke. So you were just saying you think this is composite. Why do you think it's composite? Maybe that'll give us a clue as to what these words mean.
Because I saw the 5 and saw the 5, and I just thought of 5 times 9.
Okay, so composite must mean she's like, I see a 5, so I know that, it's got a 5 as a factor. What does it mean to be composite? What does that mean?
You have, like 4, more than one of, like, what you can multiply.
The factors. You're exactly right. Okay, more than one in itself, right? So it's going to have more than 2 factors. Every number's got 1 in itself as the factors. But if that's all they have, then it's a prime number. But if you've got more than that, and we know 45, look, 1 times 45, 5 times 9. There is another one. 3 times something makes 45. Think of the clock. That might help you.
15.
3 times 15, okay, is another factor set that makes 45. So this is definitely a composite number because it has more than 2 factors. Okay, we haven't talked about that in a while. We need to mention it every now and then so we don't forget what it means. Okay, so we're kind of getting our brains warmed up. It's Monday, a rainy Monday at that, but we're good. We are good. All right, go ahead and erase your board and just kind of push it out of the way for right now. I didn't go back to the big screen target, but here it is right here where I can find common units or number of units to compare two fractions. Okay. Now, what in the world are they talking about? We're going to get to this in just a few minutes. Okay. We're going to look at a few slides and talk about them. And you remember how last week we were using this? There was a word that started with an R that we talked about. We use this up here a whole lot. What's that word that starts with an R? Okay? Yeah. We're going to do some reasoning today again. Coming up in another day or so. Let me ask you this. How many of you, it bothers just a little bit when we put some fractions on the number lines to kind of compare them, but we've kind of gone, this one goes right about here, and this one goes about here. So this one's bigger, this one's, Does it bother you that we're doing that about thing? That we're not saying this is exactly where it goes? Does that bother anybody? Sometimes that bothers people, and they want, how do you know? I want to know exactly where it goes. And if that bothers you, we're going to learn some strategies this week that will help you know for sure, 100%, if that bothers you. Even though we've been saying that, though, we've been pretty accurate with what we've been doing. All right, so simple question at first. Which is greater, 1 apple or 3 apples? You might feel like you've transported back to kindergarten for just a second. That's all right. Enjoy the simple. Enjoy the simple because it doesn't always stay there. Bailey, what's more? 3 apples, right?
That's one.
Okay.
That's one.
Now, why did they give us a question like this? Because this is what they're comparing it to. It's almost like they're saying one. I'll just draw one just for fun. Okay.
One apple.
Or 3.
One apple.
Okay.
That's a good apple.
All right, look at the second question. Which is greater? 1/4 or 3/4? Okay. I don't think you need this to help you. But just in case we're really asleep this Monday morning, what's greater? 1/4 or 3/4? Ishmael, which one? 3/4 for sure. Okay. And so I'm going to go ahead and tell you this. We're going to see words like this, like where the unit is in word form, even on our problem set today. If you see that, sometimes it's just easier if you'll write the fraction because we're so used to working with the numbers. So, okay. What do you notice about both of these? They're the same what? They're the same numbers. They're using some of the same numbers. Sure. Anything else that you notice about them? What do you want to say?
On both of them, 1 and 3, it's the denominator 4.
So both of these have the denominator 4. Okay.
Both questions have the numerator of 1 and 3.
Okay. We've got 1 and 3, 1 and 3. Anything else?
3 is bigger.
Okay. In both times, this is bigger. Okay. Yeah.
1 apple is like 1/4, and 3 apples is like 3/4.
Because that apple is kind of like a what? The 4 here is the denominator. The apple is kind of like the denominator up here. It's kind of acting like that, even though that's weird to us. Okay. All right. Was it easy to see right here which one is larger? Can you tell me why? If we've got the same denominator here, why is it easy to see if one piece or one fraction is larger than another? Reagan, what's your thought?
Because 3 pieces is bigger than 1 piece, and they both have the same denominator, so they have the same equal pieces, so 3/4 would be bigger.
So fourths are all the what?
Equal.
They're all equal. And so if we have the same size piece, it's a lot easier to tell which one's bigger. If I've got one of the, but look, if I go, okay, then what's bigger? 1/2 or, a few of these smaller ones. You see what I'm saying? It depends on the size of your piece. That's a big old piece right there. Okay? But if I'm comparing it to 3 of these aren't larger, even though there's 3 of them. So it matters if the pieces are the same size, and when the denominator is the same, the pieces are the same size. Okay, so interesting observations there. Let's keep going for a minute. So what if we ask this question? What's greater, 1/4? And again, I'm going to write them because sometimes with what we're used to, it's easier to see what we're talking about in number form. 1/4 or 1/5. All right, so that's a little different this time. What do you want to say?
1/4.
You think 1/4 is bigger? Anybody agree with that? Disagree? We're just kind of discussing and talking, reasoning together here. A lot of agreement. Okay, but the pink question. But how did you know that?
I knew that because 4 is bigger. Not bigger. Because.
Yeah, you're on the right path. Not the number 4, but Fourths are what?
Are larger than fifth.
Okay, I don't have fifths up here, but are fourths larger than fifths? Yeah, because in fraction world, when the denominator is larger, the piece is what?
Bigger.
Be careful. When the denominator is larger, the piece is smaller because it's been cut into more pieces. You know, if I cut a pizza into eighths right here, pieces are smaller. If I cut a pizza into halves, I've only had to cut it into two pieces. The pieces are bigger. Okay, so we've known that for a while. But Caleb is exactly right. This is larger right here because the pieces are larger. Okay. They both have the same what? Guys, I need your eyes. They have the same numerator. So what does that tell us? If the denominators are different, I had fourths and fifths up there, but yeah.
If the numerators is the same and you look at the denominators, and whichever denominator is smaller is the bigger piece.
Okay. I've got the same number of pieces, right? I've got one of this and one of this. And so now I just have to know which piece is smaller and which piece is larger. If I had 3 of both of these, same thing. If I have 3 of these, well, I have 3 of them and the pieces are larger. If I have 3 of these, I have 3 and the pieces are smaller. Okay? So we can look at a denominator, and when they're the same, that's helpful. We can look at numerators, and when they're the same, that's helpful. All right, you guys are pretty sharp this for a Monday morning. Which one is greater, 2/4 or 2/6? Ishmael, what do you think?
2/4.
He says 2/4. Anybody agree or disagree with that? Let me see something from everybody. Okay. Yeah, I agree too. Tell me why. I want somebody different that wasn't talking earlier to tell me why. Why is this larger than this? Go ahead. Okay, and what do we know about fourths versus sixths? Okay, and I think I can show you that this time. Here are fourths. If I have 2 of them, and here are sixths, and if I have 2 of them, you know, which side is bigger? Yeah.
2/4 is equal to 1/2,
Mm-hmm.
and 2/6 is lower than 1/2, so you know that 2/4 is bigger.
You're exactly right. What is 2/6 equal to?
1/3.
1/3. But 1/2 is still larger than 1/3, isn't it? Okay. And what you just did is give kind of a 5th grade answer, and I'm hoping you'll start seeing that. When you reduce this down to the smallest form it can go to, which would be 1/2, 1/3, with that division strategy we learned. Sometimes that helps you see things like that too. All right. Let's keep moving. We're thinking. All right. Now, here we've got to look at the direction. Draw a tape diagram to show each. Are we back to that? We are for right now. Okay. Partition the eighths in half. What fraction is now shown? Okay, we'll get there in a second. All right, so on your board, if you would draw, now listen to what we're going to do. We're going to draw 2 separate tape diagrams. We're going to draw one for 2/8, and we're going to draw one for 4/10, but we're going to put them kind of side by side, so they need to be the same size. So it'll look like kind of like a big equal sign, because if one of your tape diagrams is super large and one is super small, you can't really compare them. Okay, so one we're going to cut into eighths. and one we're going to cut into tenths. And then you'll shade what the numerator is telling you to shade. Don't get them mixed up. 2/8, 4/10. Just super quick shading, super quick drawing, because we're not staying here very long at all. Make sure that both of your tape diagrams are the same exact size. Okay, so this one needs to be the same size. Now, one of these is eighths and one of these is tenths. Had to be careful, didn't we, with how we drew our pieces, because they're close in size. Okay. Okay, I'm going to give you just a few more seconds. And then I want you to look at your tape diagram as well as mine up here on the board. Can you use this model to compare these two fractions? Now that we've drawn this, can you look at them and easily tell which one is larger?
Yes.
Sure, absolutely. And this is why we started fractions off this way in our fourth grade lessons. We drew tons of tape diagrams, didn't we? Because it helped us easily see what we were trying to figure out. Oh, definitely can tell that 4/10 is larger. Okay. Now the directions tell us to partition the eighths in half. And this is what they mean, that we're not creating equivalent fractions here. Well, in a way we are, but this is different than the horizontal lines. They just want us to make the eighths into 16ths. I'm going to go back to that color. So each of my eighths would get cut in half. Each little box, just draw a line down the center of it. Okay. A vertical line this time. We're just creating 16ths. What fraction, I kind of gave you part of it, but what fraction did we just create? Count your boxes if you need to. How many are shaded? How many are there total? Valerie, what's our new fraction? How many are shaded? Look up here if you need to. How many are shaded now? 1, 2, 3, 4. And how many are there total? 16. Okay, so 4/16 is still smaller than 4/10. But look at what we did. We just created two fractions that have the same numerator. And so, oh, well, yeah, when those become the same number, it's easy for me to see that 16th is smaller, so this is going to be smaller. Okay? Sometimes our brain is going to be harder than other times. Okay. Try not to let that distract you too much. All right. Okay. So the tape, you know what? Let's see. Before we keep going, we have just very quickly talked through several slides. What are some of the strategies that we've seen that help us know which one is larger or smaller? I'm going to put a list over here on the board. What's one of them? Yeah.
Looking at the numerator and denominator.
Okay. I'm going to separate that into two. We look at them especially if the denominator, when we first started, the denominator was either apples or fourth. The denominator was the what? It was the same. Okay? And so if the denominator is the same, we can look at how many pieces we have. We look at the numerator. Alright. Then what did we see? We had like 1/4 and 1/5. That was one of your questions. 1/4 and 1/5. We had the same what? Numerator. So we looked at the denominator to see the size of the piece. Alright. This has been on the board before. Okay. What did we just do right here? Tape diagram, but I'm not going to draw that. I'm not going to write that. I'm just going to say draw model. Because what is another one of our models? One of our models, I'll put it in parentheses, tape diagram. What is a model we've been using a lot, like last week? We don't think of it as drawing sometimes, but what?
Number line.
Yeah, the number line is definitely a model to look at. It's just not what we're used to. When I say draw something, you might think of this, not a number line. Okay. Now, what is something that goes on the number line that helped us? Yeah. Benchmark numbers for sure. Okay, and I'll put that under draw a model. Benchmark numbers. And actually, that can really stand by itself because sometimes we start using benchmarks without the number line. We'll think to ourselves, we'll reason, hey, that fraction's close to 1/2. Hey, that fraction's closer to 1. You know, we start using the benchmarks on the number line, but then we start using them even without the number line. So we'll put that by itself. Benchmarks. Okay, I'll stop there for right now. All right, so y'all have said, and we've all agreed, these are things that help us, right, compare fractions. All right, if you would, go ahead and put your top on your marker and lay it down right now. We don't need anything right now on our board. Okay, just set it aside because I need you to see this. All right. If it's really making it hard to focus, isn't it? Okay.
Nature's not happy.
That's some heavy rain, but you know what? We're going to be so appreciative of this in the spring when our plants and our grass and our trees and all that needs to grow and all that water's down in the ground. And aren't you thankful that you're already in the building and not having to go from to walk to school right now?
It makes me really
Okay. Yeah.
If we keep raining like this, I would feel bad for the water. Luckily, the rain is so hard that I can't go to school.
That what?
Luckily, the rain is so hard that I can't go to school.
Oh.
Rain makes me sleepy.
Yeah.
It
That's
makes
what
me
I'm afraid of.
sleepy.
So, everybody stand up for just a second. Stretch.
Stop rain.
Okay.
At least we have
Stretch a little bit. Let's use this as an if. It may not stop, so we're just going to keep going. All right. Go ahead and have a seat. Just a quick stretch break. All right. So give me your eyes because I want you to hear this. If all of these make it easier to compare our fractions, then if we have two fractions that don't have some of this, like the same denominator, same numerator, is there a time where we could make them have the same denominator or numerator? You know, just a second ago we had the two tape diagrams and we cut those 8s in half, and when we did that, we had 4 shaded boxes, and that 4 matched the numerator of the other fraction. right here you've got two fractions, and it says, can we make the denominators the same? I mean, first of all, if you're thinking that's asking you, are we allowed to do it? Yes, you're allowed to do it as long as you create an equivalent fraction. I can't make a bigger fraction or a smaller fraction. I just need to make an equivalent fraction. Okay. So I want you to look at these two fractions for a second. And I don't want you to raise your hand. I don't want you to do anything but look at them and think, how could I make one of these have the same denominator as the other? Okay. Is that possible? But keep in mind, you've got to create an equivalent fraction. We know how to do that. We know that earlier we multiplied the numerator and the denominator by the same number, or divided the numerator and denominator by the same number, and we got an equivalent fraction. Because when I think of 7/10 and 2/5, I mean, if they both had a 1 on the top, that'd be easy. But they don't. And so now this has gotten harder to do, unless I can change something. Okay? Anybody, now you can raise your hand. Do you notice a way to get from one denominator to the next? Reagan, what are you thinking?
You would put the 5 in every piece of the 5. You would draw a hat on every 5.
Okay. So you're trying to think of it with a model, aren't you? Okay. What if I asked you not to use a model? Like, what if I said, let's not draw anything? Is there a way to get from one to another? And it may be exactly what you're telling us to draw, but can you think of how to get us there with the numbers? Keep thinking. What are you thinking?
I did 2 times 5 equals 10, so 4 tenths.
So how did you get to the 4? You multiplied both by 2? Okay. Let me see if this is what I'm understanding that you said. Will is saying that if he does this, are we allowed to do that? Will that create an equivalent fraction? I think am I not talking clearly enough? Okay. Am I not speaking loud enough?
Yeah, you're not.
We're just.
Are we all speaking the same language this morning?
I don't know. I think speaking.
Y'all got the deer in the headlights look. Okay. Okay, we're not gonna look like that cat a few days ago. Okay, we're not gonna do that. All right. If I multiply the numerator and the denominator by the same number, do I get an equal fraction? Yes. So that would make the fraction 4/10. Do they both have the same denominator now?
Yes.
Yes. Has this just become easier to compare? If I look at 7/10 and 4/10, has that just become easier to compare? Yes. Because when they both have the same denominator, all the pieces are the same size. All I have to do now is go, who has more pieces? The 7 side or the 4 side? Which has more pieces? The 7 side. Okay. So if there is a way to make one of your fractions have the same denominator as the other, then you need to do that and make everything a whole lot easier. Okay, let's look at a few examples of this. Is there a way to make those two denominators the same? Okay. Martin, what are you thinking?
You can make the denominator and the numerator the same.
Well, right now let's just answer this question about the denominator.
You can multiply 4 by 3.
Okay, so if I multiply the 4 by 3, I've got to do what to this? Also multiply that by 3. Don't forget that step or you won't have an equivalent fraction. Okay? If there's a way to make this into this number, you've got to do it to both the top and the bottom. Okay? A minute ago we had 5 as the numerator. How many fifths was it? It was 2 fifths and 7 tenths. Okay. A minute ago we had this, and Will told us to multiply these by 2, and we got tenths. Now Martin's telling us to go, to multiply the 4 by 3 and this by 3 to get us to twelfths. What are you noticing about these numbers? Anything? Yeah. Well, we could multiply them by anything, but we can multiply this one by 3 to get over here. Okay. One of them is a factor of the other. Okay. They are also a fact family. Do you notice that? 5 and 10 are a fact family with the number 2. And that's what we multiplied by. 4 and 12 are a fact family with the number 3. And that's what we're going to multiply by. Martin is right. When we multiply both of these by 3, what is my new fraction going to be? Interesting. Now I've got 9 twelfths and 9 twelfths. So what is my symbol going to be? Equal to. Okay. I need to know if you really saw how we got there. All right. Yeah. Everybody put your thinking cap on. Love the cat pictures.
Bags on.
That looks like my cat.
I don't know if she's really nice or really not nice.
My cat
She makes me a little nervous.
The way she looks, not nice.
Yeah, I know. That's why she makes me a little nervous. Okay. What strategy? We're not really looking for the answer first. We're asking what strategy would you use? Okay. So before we go any further, let me add our new strategy. Our new strategy today is changing one of the denominators to match to the other. Change one denominator to match the other. Because once you do that, then they have the same denominator. All right. Which of these strategies, it could be any of them, which of these strategies are we going to use that's easiest to use with this? Okay. Which one? Alex, which one? Do they have the same denominator? Do they have the same numerator? Are we going to draw a model, benchmarks, or are we going to change a denominator? Look at them carefully. No, keep looking. Keep looking. You'll see it in a second. Look at those two fractions. Gage, what do you think? Do they have the same numerator? Yeah. They do. They have the same numerator, so we're going to grab that strategy. When you see two fractions that you're comparing and they have the same numerator, look at the bottom number. Look at the denominator. Which pieces are larger, fifths or sevenths, okay? Fifths are larger. So if I've got 4 larger pieces, 4 smaller pieces, which one's going to be bigger? The larger pieces. Okay. 4 larger pieces, 4 smaller pieces. Which one's going to be larger? The larger pieces. Okay. All right, we are ready to start looking at our problem set. And on our problem set, we're going to have lots of examples, lots of, compare these two fractions using one of these strategies. They're either going to have the same denominator, the same numerator. We could draw a model, and I think there's a few times where they have drawn one for us. But any time that we can change one denominator to match the other, that's another very helpful strategy. Okay? All right, let's pause right here. Let's see. Just making sure there's nothing that's... Okay. Let's go ahead and put our boards up, and we will take our break. I may leave this running. We may come back and do a couple practice problems before we jump into our workbook. Okay, so let's go ahead and put our masks on and head to line up. under this, but let's pull our whiteboard back out for just a second. Alright, hopefully if you were at home you fast forwarded through that, but let's do just a few practice problems. I feel like we'll be a little more comfortable with what we're doing today.
Somebody took a picture of it.
Okay.
Like
Alright, so let me grab this.
anybody done what would be
So if we had three fourths, you can write these fractions down, and 5/8. And we're not going to draw the models today. That's not a strategy we're going to pick today because I want us to get familiar with this new strategy. So if this is the two fractions, I think your book puts a blank there. Sometimes we've got the circle, sometimes we've got a blank. Okay, either way, we know we've got to put that symbol in there. All right, so look at your strategies. Do they have the same denominator? No, we're not going to do that, at least not at first. Do they have the same numerator?
No.
No? We're not going to draw a model today. We could sit there and reason with our benchmarks, but the thing is, guys, both of these are greater than 1/2, and so sometimes when that happens, we're not sure which one is, you know, how much bigger than 1/2 is each of them. So what are we going to do? Okay, change one denominator to another. Change one denominator to the other, I should say, not a. Okay, so how are we going to do that? Can I get from 4 to 8? Or from 8 to 4? Gage, what would I do to that 4? Multiply by 2. And if I do the denominator, I've got to also do the numerator. Okay, so my new fraction becomes, Isabella, what's my new fraction? 3 times 2 is what? 3 times 2 is 6. What's 4 times 2? Everybody, what's 4 times 2? 8. Okay. So now I've got 6/8 and I've got 5/8. That just became a whole lot easier to tell which one is larger. 6/8 is definitely larger than 5/8. Okay. So you might have suspected 3/4 was larger than 5/8, but now you know for sure. Okay. Or maybe you thought 5/8 would be larger. Now you know better. Okay. All right. Let's try just one or two. Keep forgetting that that's not. Okay. What if we had hold on. Okay. Which strategy are we going to use this time? Which strategy are we going to use this time? Valerie, what do you think? Look up here. Do they have something the same? They have the same numerator, so we're gonna look there. They have. I've got 4 of these, and I've got 4 of these. How am I gonna know which one is larger? Ishmael? 4/6 is larger. What do we know about these pieces and these pieces? I've got the same number of pieces of both of them. What do I know about these pieces and these pieces? Okay, but what do you know about these pieces? Okay, these are bigger. Smaller denominator, bigger pieces. So same number of pieces, but these are bigger pieces. So we're going to go like that. So see, I can just reason that out. I can just think that through. I don't have to draw my number lines or my tape diagram to do that. All right, let's just do one more and then we'll move on. So if I had, let's say, 2/3 and 9/15. Okay. I'm trying to figure out which is larger. Both of those are a little bigger than half. So if both of them are a little bigger than half, I'm just not sure. That one's tough. So what could I do there? They don't have the same denominator. They don't have the same numerator. But I do notice something about this and this. Guys, there's going to come a time where you can't turn one of these into the other because there's nothing to multiply by that will get you there. But is there this time? Faith, is there something that I can multiply the 3 by to get 15? Yeah, 5. You're exactly right. So we're going to multiply both of these, the numerator and the denominator, by 5 because I recognize that 3 and 15 are part of that fact family. And my new fraction will be 10/15. So we have 10/15 and we have 9/15. And wow, that just became super simple. Okay. Which one is larger, 9/15 or 10/15, everybody?
10/15.
For sure, this right here. Okay. So when they are not matching in any way, look to see if these are a fact family where you can change one of the denominators into the other denominator. Okay? And we create that equivalent fraction like that. Okay. If you will open to the problem set for lesson 14. And your book has the right page number. 70 what?
71.
71. So if you would turn to page 71. And we're going to work through some of these. I will go ahead and shut this down.